Welcome to Carlton's Math Corner. Today we're going to be adding and subtracting fractions. To begin, please make sure that you have your math journal, vocabulary packet, and then, of course, a smile because learning is fun. Okay, our target is I can add and subtract fractions. So let's look at the first model. What do you notice with this rectangle? Great observations. The first thing that I notice is that the rectangle is separated into 9 equal parts. Then I notice that 5 of those parts are shaded in red and 2 of those parts are shaded in green. And so this red represents 5/9, 5 out of 9 parts, and this green represents 2 out of 9 parts. And the total of red and green together, I notice that it equals 7 out of 9 parts, or 7/9. And so this model represents this addition problem. 5/9 plus 2/9, which equals 7/9. Notice that the ninths are common between both fractions, so the denominators are the same. And notice that in order to get the 7/9, we are adding the numerators together. Okay, so here's another model. This is a different model. This is a subtraction model. And what I want you to notice is that all 3 of these rectangles are separated into the same number of equal parts. And how many parts is that? Yeah, exactly. They are separated into 10 equal parts. This model up here has 9 shaded out of 10, and that represents 9/10. This one has 1/10 that's shaded. And then this one down here has 8 that are shaded out of 10, so 8/10. Now, notice that we start off with 9/10. Then the one below, look at the coloring. One is shaded in red, okay? And the others are shaded in white to represent 1/10. But look what happens below in this last rectangle. Where do you think the 8/10 come from? Because that has to do with something with these 2 rectangles above. Yeah, if this is 9/10 and we take away 1/10, notice that it was green. We represent 1/10 with red, and look what happens. It turned white, meaning it's been subtracted. And so what is this purple represents what is left over from the 9/10, and what is left over is 8/10. So 9/10 minus 1/10 is 8/10. Or we could say that 8/10 is the same as or equivalent to 4/5, because I can divide both numbers by 2 and get 4/5. Now, in both of these models, we see that the denominators are the same. These 2 fractions had 9ths, and these 2 fractions have 10ths. Well, in the next situation, we have a problem. We have denominators that are uncommon, that are different from each other. So look at this model. Okay, so here is 1 shaded out of 2 equal parts. And so what fraction does that represent? Exactly, 1 out of 2 is 1/2. And notice though the 2 equal parts remain, and then below that we created a model that represents 1 out of 6 equal parts. Okay. Now, where do you think the 4 out of 6 equal parts come from? Where does that come from? Yeah, exactly. Do you notice that, okay, so this was 1 out of 2 equal parts, okay? Then each of these halves were separated into 3 equal parts because if I have 3 here and 3 here, that equals 6. And that is the denominator of my other fraction. And so if this 1 out of 2 parts, if this half represents 3/6, and this 1/6 represents 1 out of 6, and we put them together, we have 3 here and 1 here. 3 plus 1 is 4. So we have 4/6 as an answer, which is equivalent to 2/3. Now, because I can divide both by the 4 and the 6, I can divide by 2. So it's the same as or equivalent to 2/3. Okay, so let's look at another model. Okay, this model also shows when we have fractions that are uncommon denominators. Okay, and notice the difference up here. We started off with 2 equal parts because that was our denominator for the first fraction. And then our next rectangle had 6 equal parts because that is the denominator of that fraction. And we noticed that a half can be separated into 3 equal parts and 3 equal parts to get our 6. Okay, so they have 6 in common. Now look at this one. This one has 3 out of 4 shaded. And then this one has 1/3 shaded. Now look at the difference between these two. This one up here, right away, the 6 was actually a number that they could both share, meaning they both had a multiple of 6. I could change this 2 equal parts, I could change it into 6. And I could change, 1/6 was already set up into 6 equal parts. Okay, now down here, little different. We have 3 out of 4, so there's 4 parts here, and 1 out of 3, so 3 equal parts here. So we need to figure out how can we separate 3 and 4 into equal parts, something that is like a common multiple of them, a common multiple of 3 and 4. And so if you look at this, notice we can separate both of them, because like I can separate 4ths into 3 equal parts, and I can separate 1/3 into 4 equal parts, and both of them, if you count them all up, they both have a common multiple of 12. Okay, so I can go from 4 equal parts and get to 12 equal parts, and I can go from 3 and get up to 12 equal parts. And so in this one, notice that we are taking away a part. So we started off with 3/4, and we are subtracting a part from it. Now, in order to figure out how much that part is, though, we had to separate them into smaller pieces, 12ths. So we could figure out how much does this yellow, if we take it away, how much are we really taking away of what we started from? We started from with the purple. We took away 1/3 from it, and we need to figure out how much do we have left. Well, if you notice, if we separate everything into 12ths, 4 equal parts here, 4 equal parts here, 4 equal parts here, look what we have. If where it stops overlapping, okay, because we're taking this part away, this is what's left over in blue. We have 1, 2, 3, 4, 5. 5/12 that is left over. So 3/4 minus the 1/3 is equal to 5/12. Another way to look at this is, how many 12ths does 3/4 represent? Now think about it. If I separate this into my 12ths, here's a 12th, here's a 12th, and here's a 12th. So each one of these is 3 of them. So this would be 3, 6, 9. So that would be 9/12 that this purple represents. How about this one? How many 12ths would yellow represent? 1, 2, 3, 4. 4/12. So this is really 9/12 minus 4/12. What's 9 minus 4? 5. 5/12. And that's where the 5/12 came from. Now, let's kind of figure out how to do this without drawing a model, okay? I have a task for you. Well, I don't know if you've seen Wreck-It Ralph before, but Wreck-It Ralph, he likes to destroy things. And then Fix-It Felix, he comes along and he fixes everything. And so Wreck-It Ralph, he has basically created fractions that have uncommon denominators. So he has wrecked all of our fractions. They no longer have a common denominator. And so now Fix-It Felix needs to come along and fix it. And so we're going to start off with these two fractions, 3/4 and 5/6. And what I would like you to see is how Fix-It Felix fixes these and finds a common denominator. So what Fix-It Felix is going to do is he's going to come along and he's going to try to find a denominator that they both share and then find an equivalent fraction for that. So let's start off with, look at our denominators is 4 and 6. So what he's going to do is he's going to list all the multiples of 4 and 6. So here are the multiples. And we can't list all of them. He wants to really bad. But I have told him numerous times that multiples go on infinitely. So Fix-It Felix, he cannot write down all of the multiples. So I have advised him that he needs to just go until he finds the first one, that first multiple that both numbers share. And so if he started writing out multiples, so 4 times 1, 4 times 2, 4 times 3, 4 times 4, 6 times 1, 6 times 2, 6 times 3, and right away he notices that they both share the number 12. And so he highlights that and he uses that information to create another fraction. So he's going to change 4ths to 12ths and 6 to 12ths. And so what he's going to do is try to figure out, okay, if I want to go from 4 to 6 or 4 to 12, what do I need to multiply that 4 by to get to 12? Well, I multiplied 4 times 1 here, 4 times 2 here, and this was 4 times 3. So we're going to multiply the numerator and the denominator by 3. And so if we multiply by 3, we get 9/12. So 3/4 and 9/12 are equivalent. How about 6? How do we go from 6 to 12ths? Well, this is times 1 times 2, so I need to multiply both by the number, by 2. And so I get 10/12. So for tomorrow, I'd like for you to try this problem on your own and become Fix-It Felix and fix these fractions. Thank you so much for joining me at Carlton's Math Corner, and have a great evening.